Okay, good morning to all. I'm starting today's lecture of Basic First Division B. I'm sharing the screen which shows the syllabus. Yes, screen is visible, friends. Now
Yes, sir.
screen is, yes,
Yes,
visible.
sir.
Okay, thank you. Vaishnavi, thank you. Aarti, thank you. Okay, in the syllabus, is it semester second, paper 4, electricity and magnetism? In last lecture, we discussing the alternating circuit. That is the what is the alternating current and what is the network and how the role of different component inside the alternating circuits. It means in alternating circuit, what is the role of the complex number? That is the complex number is the J which is known as an operator, that is A plus JB. That will be A is the that physical quantity will be known as an the complex number, because A is the real part and JB is the imaginary part. We know that the imaginary number or the operator J has an very essential importance in case of the alternating current. In case of the alternating current, in discussing the role of the inductance, capacitance and resistance. We know that the inductance is the coil, the resistance is the load resistance. It is the which is able to resist, which is able to oppose the flow of the current, that will be the resistance. And capacitance, the basic function of the capacitance is the it will be charges and discharges, means the electrostatic charge or the electrical charge will be stored inside the capacitor. There are the different parts or different types of the capacitor. We did not go in the classification of the capacitor, but the what is the role of the capacitor is importance in case of alternating current. Okay, the complex impedance, we know that impedance, reactance, admittance, acceptance, all these are the type of the resistance. That is मी असं म्हटलं होतं की हे सगळे एका भावकीतले आहेत resistance. Then resonance, that is the resonance, that is the sharpness of the resonance. After Q factor, quality factor and AC bridges. Friends, in 11th standard and 12th standard we studied the different bridges. That is the Wheatstone bridge, that is the well-known form of the bridge, Wheatstone bridge and other different types of the bridge. But here the Owens bridge is the one of the bridge which was basically used in case of the alternating current to calculate the impedances, because we know that this is the that is the one of the rectangle or the one of the parallelogram, and parallelogram has the four sides. On four side of parallelogram, four impedances are placed that will be known as Z1, Z2, Z3 and Z4. And we know that in Wheatstone bridge, that is the relation is that Z1 divided by Z2 is equal to Z3 divided by Z4. That is the impedances of the ratio of the impedances will be equivalent, and that will be used to calculate the impedances for the balancing condition. And we know that the balancing condition is the actual equivalence condition, in which the bridges, that is the impedances on both sides are actually balanced. Then the galvanometer gives the zero potential or the zero deflection, that will be known as a null deflection. We know that null deflection means the zero deflection, and that zero deflection will shows that the equivalence between the two sides of the parallelogram, and that will be the Owens bridge. And here Owen bridge is highly used to calculate the impedances in any side. Okay, after this this part of the alternating current from unit 3, we are switching toward the magnetism part, and that magnetism part is the part of the also part of unit 3rd. In magnetism, what will be going to see, that is in magnetism we know that the magnetic induction, the magnetic induction is very important key in case दादा बोला की बरोबर 12 वाजता ते तिकडून येणार आहेत. मी तुम्हाला एक 20 मिनिटात फोन करतो. ओके, ओके. Magnetostatics, and as the electrostatic, magnetostatic is very important. In magnetostatic static, the north pole and south poles are used. North pole and south poles are used. We know that in magnetostatic there is a one basic law, that is Biot and Savart's law. Biot and Savart's, these are the two name of the scientists, and who combine whose combined contribution for the magnetostatics, it will be known as an Biot and Savart's law. It is very important and basic law in case of the magnetism. If there is one of the conductor and it will be carries the current I, and if there is the any one of the due to the carrying the current I through the conductor, it will be produces the magnetization, and the magnetic field will be produces, and the strength of the magnetic field around the conductor will be different at a different point. Consider the point any point P which is at a distance R and making angle theta, then that description will be given by the Biot and Savart's law, and here Biot and Savart's law decide the quantity or the magnitude of the that is the magnetic dipole moment or the strength of the magnetic dipole moment at a point P due to the current carrying conductor I, and according to that, as the distance will be increases, the magnetic strength will be decreases, and if the distance will be decreases, the magnetic strength will be increases. And that basic Biot-Savart's law has an very high importance, very big importance in case of magnetostatic, and its application, it has and there its different application, and that application are to be studied in case in this chapter. That is its application is straight conductor. If the conductor is straight, just I am using the annotate, that is this is the conductor, straight conductor, and it will be carries current I, that is it will be carries current I. If that it will be carries current I, then the magnetic induction is produced around this conductor. Magnetic induction will be produced around this conductor. And what is the strength of that the magnetic induction at a point P, which is at a distance R, or what is the magnetic induction? Magnetic induction around the long and straight conductor carrying current I. If we take the circle of a radius R from that conductor, consider I am using here this yellow or this green, and consider that this is the radius R, and I draw the circle with the radius R. Then around the circumference of that circle, circleच्या परिघावरती, which is at same distance from the around the same distance from the long and straight conductor, then the magnetic induction on the distance 2 pi r म्हणजे तो त्याचा परिघ आहे, सर्कम्फरन्स आहे, आणि याच्यावरचं मॅग्नेटिक इंडक्शन हे सेम असतं, आणि हे मॅग्नेटिक इंडक्शनची किंवा या मॅग्नेटिक इंडक्शनची मॅग्निट्यूड काय आहे हे आपल्याला इथं, दॅट इज द application of the Biot and Savart's law in calculating the magnetic strength along the distance and along the circumference having the radius r from that long and straight conductor. It will be one of the best application for calculating the magnetic strength. And we know that if the radius of the circle will be changed, the magnitude of the magnetic field or the magnetic strength, it will be changes. Okay, consider the circular coil. Just I am erasing the annotation here. Just I am going to erase the annotation here, and consider that the new annotation, we considering the new annotation. Okay, and here is the circular coil. Consider this is the circular media, and through which there is the coil, and that coil will be circular coil, friends. That will be the circular coil, and in this way this is the coil, and circular coil, that circular coil carrying current I, it will be carries current I, that will be carries current I. Then what will be the phase? That is the circular coil. Consider that is the insulator is there. On insulator coil is to be wounded, and the circular insulator on which the coil is wounded, and through coil current I is flowing. Then we know that if the coil current carries current I, then magnetic induction due to the law of magnetization, the magnetic induction is to be formed. And here we have to calculate the magnetic strength along the axis of the coil. That is, this is the axis of the coil, and along the axis of the coil, what is the magnetic strength? We have to calculate. Along the either along the distance or from the axis of the coil, we have to calculate the magnetic induction. And this is the here the Biot-Savart's law is very applicable in this process. That will be known as an, again we are going to see the Ampere circuital law, that is closed coil will be endless, that is the starting and ending point are the same, that will be known as an endless coil. And that endless coil having if through that coil the current I will be passed, then what is the magnetic strength of the magnetic field, and magnetic strength of the magnetic dipole moment, it will be calculated from the Biot-Savart's law. And this is the application. This is the one of the best application in magnetostatic, and where the Biot-Savart's law is used. It means the circular coil, we take the circular coil in the shape of the circle, and through that insulator, if the coil is to be wounded, and if through which the current I is to be passed, and we know that any shape of the coil there, immaterial about the shape of the coil, if there is the conductor is present, and through which the current is to be passed, then the that is the magnetic field is produced due to the Faraday's law or due to the Lenz's law. That is the due to the magnetization, the magnetic field is to be produced, and the strength of that magnetic field is to be calculated according to Biot-Savart's law. And in case of circular coil, also it is to be calculated. It will be easily calculated in this case. Just I am erasing this diagram, that showing the case of the circular coil. Then this is the very best example of the magnetization or the magnetostatics. Here is the solenoid. Solenoid means the long and straight insulator. Solenoid means the long and straight insulator on which the small current carrying conductor is to be wounded. And if there is the solenoid which is carrying current I, then if that solenoid carries current I, then intensity of the magnetization and magnetic field is to be produces around that solenoid. And what is the magnetic strength of that magnetic strength of the magnetic field along the axis of the solenoid? It is to be calculated here. Here, consider this is the, just I am taking the annotate here. Friends, this is the long and straight solenoid. This is long and straight solenoid. Means it is the insulating part. Means it is the insulating part. इन्सुलेटर आहे म्हणजे लाकूड आहे, प्लास्टिक आहे. असा प्लास्टिकचा दांडा घेतला, लाकडाचा दांडा घेतलेला आहे, आणि याच्यावरती मित्रांनो काय केलं आपण, याच्यावरती आपण कॉईल वाउंड करतोय बघा, अशी कॉईल वाउंड करतोय. अशी कॉईल वाउंड करतोय, त्याच्यावरती गुंडाळतोय आपण कॉईल. Just see, there is the insulator at center. It may be wood or plastic. and on which we wounded uniform insulating wire. ही पलीकडच्या बाजूला आली वायर आणि इथंच याचा शेवट पलीकडच्या बाजूला आहे, अशी वायर आहे वायर. मी वाउंड केलेली आहे वाउंड. If I uniformly insulating wire, that is the conductor is wounded on a uniform insulating wire is wounded on a insulator, long and straight insulator like a wood, like a plastic, like a paper. Okay, मी हे सेंटरला जे घेतलेलं आहे मित्रांनो, आणखीन फार चांगल्या पद्धतीने मी तुम्हाला दाखवतो इथं. हा सेंटरला जो इन्सुलेटर आहे, इन्सुलेटर हा त्याचा ऍक्सिस आहे, ऍक्सिस ऍक्सिस आहे, ऍक्सिस इन्सुलेटरचा ऍक्सिस आहे मित्रांनो. ओके, आणि हा इन्सुलेटर आहे. आता इन्सुलेटरवर युनिफॉर्म इन्सुलेटिंग वायर वाउंड केली आणि यातून मी करंट आय पास केला, करंट I पास केला मित्रांनो. करंट I will be passed through uniform insulating wire which is to be wounded on the long and straight insulator that will be known as an solenoid. हा सोलिनॉइड झाला. मी सेंटरला एबोनाइटचा दांडा आहे, वुडनचा दांडा आहे, प्लास्टिकचा दांडा आहे किंवा पेपरचा रोल आहे. याच्यावरती मी वायर काय केली, वाउंड केली. वायर मधून मी करंट आय मी काय केला, करंट आय मी पास केला वायर मधून. आता काय होईल सांगा, इफ करंट आय इज टू बी पास्ड थ्रू युनिफॉर्म इन्सुलेटिंग वायर ऑन अ सोलिनॉइड, then it will produces magnetic induction around that wire. आणि त्यामुळे काय होणार आहे मित्रांनो, मॅग्नेटिक इंडक्शन, याच्या भोवती मॅग्नेटिक इंडक्शन तयार होणार आहे. आणि हे जे मॅग्नेटिक इंडक्शन असणार आहे, हे मॅग्नेटिक इंडक्शन जे असणार, हे असं असणार आहे मॅग्नेटिक इंडक्शन. सगळ्या स्वभावात त्याच्या स्वभावात हे काय असणार, मॅग्नेटिक इंडक्शन असणार आहे. मला काय करायचंय, देर इज द सोल्युनाइड दॅट इज द सेंट्रल इन्सुलेटर and I have to calculate the magnitude of that magnetic field along the axis of the solenoid. हा जो रेड, मी सेंटरची रेड रेषा आहे ना, ही सेंटरची रेड रेषा आहे, ती ऍक्सिस आहे मित्रांनो. आणि हा जो ऍक्सिस आहे मित्रांनो, या ऍक्सिस वरती मला काय करायचंय, ऍक्सिस वरचं मॅग्नेटिक फील्ड कॅल्क्युलेट करायचंय, स्ट्रेंथ ऑफ द मॅग्नेटिक फील्ड कॅल्क्युलेट करायचंय. इफ दिस इज सोल्युनाइड, if this is the insulator on which the uniform magnetic wire is to be wounded and through which the current I is to be passed, then the magnetic field is to be produced around it, and we have to calculate the magnetic strength of that magnetic field along the axis of solenoid. And for this condition, for this application, also the Biot and Savart's law is to be used. And here, the basic application of the Biot or Savart law is very, very essential in this case to calculate the magnetic induction along the axis of the solenoid having long and straight solenoid on which if uniform magnetic wire is to be wounded. In this case, also the Biot and Savart's law is highly used. Here just I am erasing this. Okay. Next we are going to see the next point, that is the divergence. Separate divergence and curls of the magnetic field. This is mathematical part, that is the divergent part of the magnetostatic and curl part of the magnetostatic. Madhusudan, please mute yourself. Madhusudan, please mute yourself. Madhusudan, please mute yourself. Okay, thank you, Madhusudan. The magnetic vector, then magnetic vector potential. That is, magnetic vector potential is again one of the physical quantity and it will be calculated here. Then Ampere circuital law is very, very important in case of the magnetization and in case of also magnetostatics. That is the Ampere is the name of the scientist and who searched the one of the basic law in case of the endless solenoid or in case of the circular conductor. Consider there is the solenoid. In last case we consider here annotate, and in last case we see the straight solenoid. But here the solenoid is the circular. Consider that this is the circular solenoid. Solenoid is the circular solenoid. This is the circular solenoid. Okay. If this is the circular solenoid, and around which again we take the annotate, and like that we consider that the around which again the magnetic field, that is the uniform insulating wire, is to be wounded around around it, and through that uniform insulating wire, again the current will be passed, current I will be passed through that uniform insulating wire. Then what will be the condition? In last case we take the straight solenoid, long and straight solenoid. Here we are going to take the endless solenoid. Endless solenoid means that is the endless solenoid. In endless solenoid, it is the circular solenoid, that is the starting and ending point is the same. The circle is the starting and ending point is the same. Starting and ending point is same. That is the circle. If we take the circular solenoid and around which the uniform insulating wire is to be wounded, then in this case, uniform insulating wire is to be wounded, and through which if the current I is passed, then again the magnetic field is to be produced around the uniform circular wire, and that uniform strength of the magnetic field is to be calculated according to Ampere's theorem, and that law will be known as an Ampere circuital law, or the Ampere theorem. It will be famous in the name of the Ampere, that is Ampere circuital law or Ampere's theorem. It will be famous in this sense. Then magnetic properties of the material, that is that there are the different magnetic material, that is ferromagnetic material, paramagnetic material, diamagnetic material, ferrimagnetic material, that antiferromagnetic material, antiferrimagnetic material. There are the different types of the magnetic material according to the magnetic strain, according to magnetic properties. That is diamagnetic material, that is the material which does not attract toward the magnet. The material which does not magnetize in magnetic field, that will be known as a diamagnetic material. The ferromagnetic material, the material is highly attracted by the weak magnetic field. That is the material which is highly attracted by weak magnetic field, which will be known as an ferromagnetic material. That is diamagnetic material. It does not attract by the also strong magnetic field. Strong magnetic field मध्ये जरी ठेवलं तरी ते अट्रॅक्ट होत नाही, किंवा if we'll increase the strength of the magnetic field, strong magnetic field ची strength जरी वाढवली, again it does not magnetize. That will be known as an diamagnetic field. Diamagnetic material, the ferromagnetic material which shows the magnetic behavior, the diamagnetic material which does not shows the magnetic behavior. Then paramagnetic material, it will be shows in some condition, in some parameter. If the parameter is changed, its magnetic properties are to be changed. Very interesting area of the magnetic materials, or the property of the magnetic material. This is very interesting area of the study, and it will be highly important for the future research in the front areas of the physics. We know that the invention or the research does not stops. Research कधी कोणासाठी थांबलेला नाहीये. It does not stops it will be increases, it will be go on, and due to this, friends, increase in the research, the magnetic properties are very essential. And according to magnetic properties, we categorize the different magnetic materials. That is, this is paramagnetic, this is antimagnetic, this is ferromagnetic, this is the diamagnetic. This classification will be made, and according to the properties, their structure, magnetic structure will be changes, and this interesting area will be studied in this topic. Then magnetic intensity, magnetic induction, permeability is the one of the property. Permeability, it will be shown by this side. Magnetic susceptibility, and the brief introduction of the diamagnetic, paramagnetic, ferromagnetic materials. And here we are going to study the different properties, different properties of the paramagnetic, different properties of the ferromagnetic, different properties of the diamagnetic material, and the classification of the material is to be done here. Friends, classification of the material is to be done here, and in this way we are going to study this chapter. In this chapter we are going to make the different, we are going to categorize the different magnetic material, we are going to categorize the different properties, how the property is to be depend on that magnetic material, and what is the basic application of that property in case of the magnetostriction or the magnetic behavior of that matter, how the properties are essential, or in which rate that magnetic property will be changes according to parameter, that will be seen in this chapter. It means that friends, these two topic, that is the alternating circuit as well as the magnetism, are very essential for the research aptitude, because we know that after the BSc we are going to MSc, and there is the, after the MSc there is the vast field of the research. Our number of students are working in abroad in research. They are making the postdoctoral study, they are working with the different NGOs in abroad. They are some of our students are working in India also with the NGO, and this is the area of the front area of the physics. फिजिक्सचा तो भविष्यातला काय आहे मित्रांनो, भविष्यातला रिसर्च आहे. आपण इथं थांबतोय मित्रांनो. फास्टली, फक्त ओनली 2 minutes आर रिमेनिंग to exit the meeting. Please submit your attendance in chat box fastly. Submit your attendance in chat box. Okay, fastly submit your attendance in chat box. I am stopping here the sharing. मित्रांनो, लगेच फास्टली आपला अटेंडन्स चॅट बॉक्स मध्ये द्या. नेक्स्ट पिरियड पासून आपण डिरेक्टली सिलेबस सुरू करतोय, टेस्ट सुरू करतोय ऑनलाईन. घाबरायची गरज नाही. कदाचित तुमची परीक्षा होईल, नाही होईल, कशी होईल काही सांगता येत नाही. दिस इज पॅन्डेमिक सिच्युएशन, अँड हे जे पॅन्डेमिक सिच्युएशन आहे, या पॅन्डेमिक सिच्युएशनला आपण फेस करतोय. नेक्स्ट लेक्चरला मी तुम्हाला बऱ्यापैकी अवेअर करणारच आहे मित्रांनो. 2 प्रकारच्या लसी आहेत, कोविशिल्ड अँड कोवॅक्सिन. मला माहित आहे आपल्याकडे या वॅक्सिनच्या बाबतीत फार अवेअरनेस नाही आहे. मी सहज परवा एक सर्वे केला कोडोलीमध्ये. मी जवळजवळ 36 ते 37 जणांना, ज्यांचं वय 45 वर्षापेक्षा जास्त होतं, त्यांना मी विचारलं तुम्ही वॅक्सिन घेतला का, तर अनेक जणांनी वॅक्सिन घेतला नाही मित्रांनो. आणि आपण बघितलं फॉरेन मध्ये, अब्रॉडच्या अनेक कंट्रीज, US घ्या, ऑस्ट्रेलिया घ्या, इटली घ्या, याच्यामध्ये व्हॅक्सिनायझेशनचा रेट वाढवल्यामुळं तिथला कोरोनाचा रेट कमी आलेला आहे. मित्रांनो, आपल्या घरी आपले एल्डर सगळे रिलेटिव्ह असतात, आपले आई वडील, काका काकी, मावशी, त्याचबरोबर आपली बहीण, मोठा भाऊ, चुलते, हे सगळे जणांनी वॅक्सिन घेतलेली नसेल तर त्यांना व्हॅक्सिनायझेशन करायला मित्रांनो अवेअर करा. 18 पासून 40 पर्यंत व्हॅक्सिनायझेशन 1 तारखेपासून सुरू करते गव्हर्नमेंट. तुम्ही रजिस्ट्रेशन करा, सगळ्यांना व्हॅक्सिनायझेशन साठी अवेअर करा. ओके, अवेअर करण्याबाबतचं माझं अपील आहे मित्रांनो. तुमच्या पाहुण्यांना, मित्रांना, मैत्रिणींना सगळ्यांना सांगा की जेणेकरून ते आपल्या सगळ्या फॅमिली मेंबर्सचं वॅक्सिनायझेशन करतील आणि या डेंजरस डिसीज पासून आपण थोडंसं प्रोटेक्ट होऊ. ओके मित्रांनो, उरलेल्याने ज्यांचं कोणाचं उरलेलं आहे त्यांनी जरा फास्टली अटेंडन्स सबमिट करा. मी अटेंडन्स काय करतोय, सेव्ह करतो आहे. मी अटेंडन्स सेव्ह केलेला आहे आणि मीटिंगचा वेळ संपेल, आपण सगळे मीटिंग मधून बाहेर पडू. ओके, पुढच्या मीटिंगला आपण भेटू. हॅव अ नाईस डे, स्टे होम, स्टे सेफ. थँक्यू.